All right, tonight's topic, we're going to do two things. We're going to review what the derivative means in the context of the problem and L'Hopital's rule as well. So our first example comes from an AB exam 2001. So you probably don't need to copy everything down in your notes, perhaps just, the main part of the question there. All right, so the temperature in degrees Celsius. So things I'm going to highlight. We're talking about the temperature. Our units are degrees Celsius. Of the water in a pond is differentiable. The table at the right shows the temperature recorded every 3 days over a 15-day period. So use the data from the table to approximate W prime of 12. Show the computations that lead to your answer and indicate units of measure. So you can see that this was a 2-point question, one for your work and one for your answer with the units. Okay, so if you missed the units, you lost 50% of that question. Or that part of the question. So it's really important that you kind of underline and highlight as you're going through this exam. So W prime of 12 is pretty straightforward. We've done this a million times, I think. I want the slope at 12, so this is W. I want W prime. We are always picking the two numbers that surround it, even if it's on the table. So I'm going to do W of 15 minus W of 9 all over that 15 minus 9. Now, the other thing I'm going to do is I'm going to write the units down so I don't lose that right away. The W of 15 gets me 21 minus 24, and here's where I'm writing those units down, degrees Celsius, divided by 15 minus 9, 6, and that represents days. So if I screw something up, I've already got those units written down, and I don't have to worry about it at the end. So I think that gives me a negative 3.6, which is obviously a negative 1/2 degrees Celsius per day. Okay, now here's kind of the big part of the question. What if you were asked to interpret the meaning of the approximated derivative value we found in example 1? So we've tried to come up with a silly little acronym to help you because some of us seem to be struggling on writing these. So perhaps let's get this down. The acronym is NUT. So what are the things you have to have? The noun and number in your sentence. The noun meaning the subject of the problem and the numerical value. And they're usually going to say in the context of the problem. And that's why I've kind of underlined for myself what this was about. It was the temperature of the water in a pond. You're going to need the units. We can't miss that in the description, in the interpretation. Label with appropriate units and the time. Include the at word, at blank, okay? And that's given to you, so that's kind of the easiest part. So interpret the meaning of the derivative from part A in the context of the problem. So again, anytime I take the derivative, I'm starting with my sentence, the rate. Rate is that 4-letter word, so highlight that in your notebook there. 4-letter word for derivative. The rate. And now I'm going to kind of describe what's happening. The subject of the problem and the numerical value. The rate, and I cannot go up and kind of highlight here. We're talking about the water in the pond. Oops. At which the temperature, so now I'm describing the subject of the problem, of the water in the pond, is, and because that answer was negative, I'm going to say is decreasing at 1/2 degrees Celsius per day at the 12th day. And let me just kind of go back and see if we hit NUT. Do we have the noun and the number? Okay, so again, I have the word rate because we took a derivative. The noun, what are we talking about? The temperature of the water in the pond. The number is 1/2. Now I didn't put the negative in because I said it's decreasing. So we're not going to count that negative twice. It's decreasing at a rate of at 1/2 degrees Celsius per day. So I've labeled with appropriate units. And I'm including the time at the derivative change was compounded, at the 12th day. All right, let's try another one. So again, here's from the 2013 exam, question 1. On a certain, and I don't think you need to write all this out, kind of maybe just those in key words. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant, it's kind of a mouthful, is modeled by this function, where T is measured in hours, and they give you this interval. At the beginning of the workday 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, the gravel is processed at a certain rate. Using your units, we want to find G prime of 5. So mathematically, this is super simple. This is in Y1. It says it's calculator active. I'm going to find G prime of 5. So again, just to be clear, that's Y1. I'm hitting math 8 of Y1 at 5 and jotting down my value there. So I'm going to, let's see, I think I did that already. I have negative 24.588. Okay, now I've got to have my units. Okay, so using correct units, interpret the answer in the context of the problem. So there's that bit question. Interpret the answer in the context of the problem. So let me go back to my units. This was measured in tons per hour. Okay, so G of T is tons per hour, and I just took its derivative. So I'm adding on a rate, a per something. So I'm going to get tons per hour per hour. I have to add on the rate part. So again, I'm getting tons per hour. That's what the function was. Its derivative is per hour. Okay, so now let's put our sentence together. What the heck are we talking about? So again, I took the derivative, so I'm starting with the two words, the rate. Okay, so now I'm going to go to nut. What is the noun? What is the subject? And the number. The rate of what? What are we talking about? Well, we underlined it. Unprocessed gravel arriving at a plant. Whoops. Plant is decreasing. Why decreasing? I got a negative answer at 24.588 NUT. So now I'm using my units. Tons per hour or tons per hour squared. Specifically at, use my capital AT here. We have to describe when. What did that 5 represent? Well, T is measured in hours. So specifically, you could technically say at T equals 5 or at the 5th hour. Saying T equals 5 is perfectly fine as well. Okay, so try to get this NUT acronym in your head. Let's see, we've got one more to tackle here. The wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature. This was a nasty question. In degrees Fahrenheit, I feel like there's a lot of units here. So the first, they're describing wind chill. It's the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit. And the wind velocity is measured in miles per hour. Then they give you this function for wind chill. Find W prime of 20. So mathematically, piece of cake. W prime of 20, again, they're telling me it's calculator active. I'm throwing this in Y1. I'm hitting math 8 at 20. And again, you can verify this on your calculator. I'm getting negative 2.86. Okay, now we got to talk units. The derivative of W is measured in degrees Fahrenheit. So this is degrees Fahrenheit per, because it's a rate, per the function inside, which is measured in miles per hour. Okay, so I get degrees Fahrenheit per miles per hour. All right, so now we have to interpret this in the context of the problem, of course. So we took a derivative. So again, we're going to start with the words the rate. And then we're going to use that NUT acronym. Okay, so what is the noun? What are we talking about? The rate, and again, this was the wind chill. And again, I'm going to say is decreasing because I got a negative answer. is 0.286 degrees Fahrenheit per miles per hour. And then I need that specifically at time, at or at whenever. And that 20 represented the V value, and V was measured in miles per hour. So at 20 miles per hour. Again, technically, you could say at V equals 20, and that would be perfectly fine as well. All right, so one of our big goals tomorrow is writing these perfect sentences. So a little detail we want to get right. And then lastly, we have L'Hopital's rule that I want to go over just one last time before the exam here. So again, if you have one of the two of the following cases, you're going to use L'Hopital's rule. So if both f of x and g of x equals 0, so again, you're getting 0 over 0, or you get an infinity over an infinity, or a negative infinity over negative infinity. All of these are L'Hopital questions. Typically, we see the 0 over 0 most often, but every now and then one of these infinity ones will pop up. And then again, mathematically, it's simple. You just derive the bottom and derive the top. But don't forget, we have to show these two steps according to the AP, and that's kind of our big setback or dilemma on some of these. So let me just run through example 1. So I'm going to take the limit as x approaches 2 of just the numerator. So I've got 3x squared minus 7x plus 2. And I'm going to take the limit as x approaches 2 of just the denominator. I'm going to do the denominator first because that looks super easy. I got a 0. Let's see, 2 squared is 4, so that gets me a 12 minus 14 plus a 2. 12 and 2 is 14, minus 14, I get a 0. This is the part you have to show those two separate steps. So I just do it right off the bat because typically most of these questions on our exam are L'Hopital. Not always, but typically. So I've kind of stated them separately. So now I can go through and apply L'Hopital's rule. So the limit as x approaches 2, and I'm just going to derive the top. So I've got 6x minus 7 all over 1. And again, I'm going to go the limit as x approaches 2 of 6x minus 7. And the limit as x approaches 2 of 1. So let's see, 12 minus 7 is 5, and the limit as x approaches 2 of 1 is 1. So I think I get an answer of 5. 5 over 1, or just 5. Okay, but again, the whole point of me going over this is that you have to show those two steps separately. So I've just found a couple uglier questions I thought we'd run through. So let's go ahead and do so. I'm just going to kill this example 3. It goes to the next question. So again, I'm going to separate them. The limit as x approaches 1 of the numerator, and the limit as x approaches 1 of the denominator. So take a moment, plug in your 1, and see what you get for each of those. So again, just to remind you, this is the ln function. The ln of 1 is 0, so I get 0 minus 1 plus 1, which of course is 0. Here I get e to the first minus e times 1. E to the first is e minus e is 0, so I am getting 0 over 0. So I can go ahead and apply L'Hopital's rule. And I'm just running out of room here, so I'm going to take the limit as x approaches 1, and I'm going to derive the top and bottom. So the ln of x becomes 1 over x minus 1, and then plus 0. The derivative of the bottom, the derivative of e to the x is e to the x. How about the derivative of ex? What if I said minus 6x? How simple is that derivative? It's just a minus 6. So this is just a minus e. Okay, and then we're going to do the same thing. I'm just going to erase some of this. We need to go ahead and substitute in the 1 to both the numerator and denominator. And again, I'm going to do it separately because I'm anticipating these L'Hopital questions. So I've got the limit as x approaches 1. I have 1 over 1 minus 1. And the limit as x approaches 1 of e to the first minus e. Oh shucks, 1 minus 1 is 0, and e to the first minus e is 0. So I've got L'Hopital a second time. And again, that's why I'm keeping them separate. This turned out to be a second L'Hopital question. So I'm just going to keep erasing for some room here. Sorry about that. And derive, again, the numerator and denominator. So remember, you can use L'Hopital as many times as needed typically it doesn't happen more than twice. So I'm going to go the limit as x approaches 1, and I need to derive the top. So again, I'm going to rewrite this 1 over x as really x to the negative 1 when I take its derivative. So I'm getting negative x to the negative 2 all over the derivative. So 1 becomes a 0. E to the x is e to the x. E, of course, is a constant, so that becomes a 0. And then I'll just go back and substitute my 1 in again. So I'll give you a moment. Substitute your 1 in to the top and bottom and see what you get. So I'm just going to rewrite this as negative 1 over x squared. So when I substitute a 1 in here, I think I get a negative 1. And here I get e to the first, just e. So I would say my final answer is negative 1 over e. So again, I just applied L'Hopital's rule twice. All right, so next question is a little graphical version. So I want the limit as x approaches 3. So again, I'm anticipating most of these to be L'Hopital, so I'm just going to separate them from the get-go in these free responses. So I'm going to take the limit as x approaches 3 of the numerator and the limit as x approaches 3 of the denominator. So let's see, 3 squared is 9 minus 9 is 0. And then this is a graph of f. F of 3 is 0. So I'm definitely getting a L'Hopital question. So now I can apply L'Hopital because I've written them separately. Derivative of the numerator, so that's just f prime of x, divided by the derivative of the denominator, which is 2x. So now again, I'm just going to find each limit separately. Setting the limit as x approaches 3 of f prime of x, and the limit as x approaches 3 of 2x. That one's pretty simple. I'm going to get a 6 there. All right, so I need the limit as x approaches 3 of f prime of x. So again, I'm staring at a graph of f of x. If I want f prime of x, instead of looking at the value here, I'm going to look at the slope here. And again, the slope of something linear, everybody on this line has the same slope. So I'm just going to pick 2 points. I'm literally going to count them. I'm going to go down to over 1. So I'm going to say that line has a slope of negative 2. So it looks like I get a slope of negative 2/6, which obviously can reduce to negative 1/3. And I've got one last question from a more recent exam. This is from the 2018 exam, question 5. So last question here, they give us f of x, they give me something about g, and they want us to take this limit. So again, I'm just anticipating L'Hopital on all limit questions. Not that it's going to be, but I'm going to anticipate it. So I'm just going to write each one separately. And evaluate. All right, so let's take the easy one. I need g of pi over 2. And why am I calling this the easy one? Well, they gave it to us. G of pi over 2 is 0. All right, so now I need f of pi over 2. That one's going to require a little bit of work. So they gave me f. I just got to carefully plug it in. So I get e to the pi over 2, which starts to freak people out, but I'm multiplying it by the cosine of pi over 2. And if I picture this graph, the cosine of pi over 2 is 0. So I get e to the pi over 2, which is scary looking, times 0, which of course is 0. So it does turn out to be a L'Hopital question. I am getting 0 over 0. So I've written them separately, which saves me some time. So now I can just go through and derive. So I have the limit as x approaches pi over 2. All right, the derivative of the numerator, f of x, becomes f prime of x. That's an easy derivative. The derivative of the denominator is g prime of x. So again, that's an easy derivative. So take a moment and just write out both limits separately and see what you can come up with. So again, I'm going to tackle the easy one first. This happens to be a graph of g prime. So g prime of pi, I don't know why I put 0 over 0 for each of those. Hold on. I'm getting way ahead of myself. I'm just loving this L'Hopital stuff. So I need g prime of pi over 2. So again, this is g prime. Here's pi over t, 2. So g prime of pi over 2 is 2. So that was the easy one. Now I need f prime. Well, remember, they gave us f. So I have to slow down and go get f prime. So f back here was e to the x times cosine of x. So f prime. So I'm going to go first times the derivative of the second plus the second times the derivative of the first. So fairly simple product rule. I just now have to plug in pi over 2, which again isn't that bad. It's going to look a little ugly with the e's, but we're just going to go with it. So let's see, I get e to the pi over 2 times negative sine of pi over 2 plus the cosine of pi over 2 times e to the pi over 2. And again, this cleans up pretty nice because the cosine of pi over 2, like we just drew out before, is a 0, so that wipes this side out. Now I need the sine of pi over 2, so I'll just kind of graph that as well. 0, 1, 0, negative 1, 0. So the sine of pi over 2 is just 1. So I think I get negative e to the pi over 2 all over 2. And that's how I would attack that L'Hopital question. So you can see that they pop up pretty frequently. And again, I think on the short answer, if you just separate them from the beginning, you don't have to over stress about just kind of what you get on top and bottom. So 2 things we're going to cover in class tomorrow, and I look forward to seeing you.